Imagine a time long ago, a world where the mysteries of the universe were just beginning to be explored. The year is 287 BC, a time when ancient civilizations were flourishing and knowledge was highly prized. The place is Syracuse, a Greek city in Sicily, known for its rich culture and intellectual pursuits. In this vibrant city, a brilliant mind is born. His name is Archimedes, a name that would echo through the ages. Even as a young boy, Archimedes showed great promise. He was curious, always eager to learn and understand the world around him. He was fascinated by the world around him, from the smallest pebble to the vastness of the sky. Nature was his playground and his classroom. He loved to solve puzzles and find new ways of doing things. His inventive mind was always at work seeking solutions to problems. As he grew older, Archimedes' genius became more and more apparent. His insatiable curiosity and relentless pursuit of knowledge set him apart. He excelled in many fields: mathematics, physics, engineering. His contributions were vast and varied, each one more impressive than the last. He was a true polymath, a master of many disciplines. His intellect knew no bounds, and his work influenced countless others. But it was in mathematics that Archimedes truly shone. He made groundbreaking discoveries and developed new theories that would change the course of history. His work laid the foundation for modern mathematics. His legacy is a testament to the power of human curiosity and the endless pursuit of knowledge. Many stories surround the life of Archimedes, one of the greatest mathematicians and inventors of ancient Greece. His contributions to science and mathematics are numerous, but perhaps none is as famous or as captivating as the tale of the Golden Crown. One of the most famous is the story of the Golden Crown, a tale that has been passed down through generations, illustrating not only Archimedes' brilliance, but also his keen observational skills and innovative thinking. The king of Syracuse, Hero II, had commissioned a new crown to be made of pure gold. He wanted to offer it as a votive gift to the gods, a symbol of his devotion and wealth. However, the king suspected that the goldsmith might have cheated him by substituting some of the gold with silver. This suspicion troubled the king greatly, as he wanted to ensure that his offering was genuine. The king asked Archimedes to determine if the crown was pure gold without damaging it. This was a challenging task, as traditional methods of testing the purity of gold would have destroyed the crown. This was a difficult problem that required a non-destructive method to solve. Archimedes, known for his ingenuity, took on the challenge with great determination. Archimedes pondered it for days, thinking deeply about how he could solve this puzzle. He knew that the answer lay in understanding the properties of gold and silver, but he needed a breakthrough. One day, as Archimedes was taking a bath, he had a sudden realization. As he lowered himself into the tub, he noticed that the water level rose, and it struck him that this displacement of water could be the key to solving the problem. He noticed that the water level rose when he got into the tub, and he realized that the volume of water displaced must be equal to the volume of the part of his body he had submerged. This principle could be applied to the crown. He realized that he could use this principle to measure the volume of the crown. By comparing the amount of water displaced by the crown to that displaced by an equal weight of pure gold, he could determine if the crown was made of pure gold or if it had been adulterated with silver. Overjoyed with his discovery, he jumped out of the bath and ran through the streets naked, shouting, "Eureka! Eureka!" which means, "I have found it." His excitement was so great that he forgot to dress himself. This word, meaning "I have found it," became a symbol of scientific discovery and innovation. The Eureka moment is now synonymous with a sudden, brilliant insight that solves a complex problem, a testament to Archimedes' genius and the timeless nature of his contributions to science. Archimedes possessed an exceptional grasp of geometry. He was particularly fascinated by circles and spheres. He made significant advancements in calculating their properties. One of his most remarkable achievements was determining the value of pi. Pi represents the ratio of a circle's circumference to its diameter. Archimedes devised a method to approximate pi with astonishing accuracy. He also developed methods for calculating the surface area and volume of spheres. His work in this area laid the groundwork for integral calculus. His insights into geometric shapes were centuries ahead of his time. While Archimedes did not explicitly develop calculus, his work paved the way for its eventual discovery. He introduced concepts that would later form the foundation of this crucial branch of mathematics. His method of exhaustion, used to approximate areas and volumes, foreshadowed the integral calculus developed centuries later. He used infinitesimally small quantities to solve geometric problems. This approach anticipated the concept of limits, central to calculus. Archimedes' work on levers and centers of gravity also contributed to the development of physics and engineering. His insights into the principles of mechanics were groundbreaking. Section 5, the Archimedes Principle, a legacy of buoyancy. Perhaps Archimedes' most famous discovery is the principle of buoyancy that bears his name. This principle states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. This principle has wide-ranging applications. It explains why ships float. It is essential in designing submarines. It is even used in medicine to measure body density. The Archimedes principle is a testament to his deep understanding of physics. It demonstrates his ability to observe the natural world and derive fundamental principles. Section 6, War Machines and the Defense of Syracuse. Archimedes' genius was not confined to the theoretical realm. He also applied his knowledge to practical problems. During the siege of Syracuse by the Romans, he used his engineering skills to defend his city. He designed ingenious war machines. He created powerful catapults that launched heavy stones at enemy ships. He devised a system of mirrors that focused sunlight to set Roman ships ablaze. These stories highlight Archimedes' practical ingenuity. They demonstrate his ability to use his knowledge to solve real-world problems. Section 7, Archimedes' enduring impact. Archimedes' contributions to mathematics and science are immeasurable. His work laid the foundation for many fields of study. His ideas influenced thinkers for centuries to come. His rigorous methods and emphasis on proof are hallmarks of modern mathematics. His work in geometry and calculus continues to be studied and admired today. His discoveries in physics, particularly the Archimedes principle, remain fundamental concepts. His legacy as a scientific pioneer is firmly established. Section 8, Tributes to a Mathematical Giant. Archimedes' brilliance has been recognized by some of history's greatest minds. Galileo Galilei referred to him as superhuman. He praised Archimedes' use of mathematics to explain natural phenomena. Isaac Newton acknowledged Archimedes' influence on his own work. He saw Archimedes as a giant whose shoulders he stood upon. The renowned mathematician Carl Friedrich Gauss considered Archimedes one of the three greatest mathematicians of all time, alongside Newton and himself. Section 9, Conclusion. The undisputed father of mathematics. Archimedes' legacy as a mathematical genius is undisputed. His groundbreaking discoveries, his rigorous methods, and his innovative approaches to problem-solving have left an indelible mark on the world. From the principles of buoyancy to the invention of the Archimedean screw, his contributions are vast and varied. His work laid the foundation for many scientific advancements that followed. Archimedes' methods were not just about solving problems, they were about understanding the underlying principles that govern the natural world. His ability to blend theoretical mathematics with practical applications set him apart from his contemporaries. His work continues to inspire mathematicians, scientists, and engineers today. His pursuit of knowledge, his passion for discovery, and his relentless curiosity are qualities that resonate with modern scholars. The principles he established are still taught in classrooms around the world, and his inventions are studied for their ingenuity. Archimedes' dedication to rigorous thinking and his methodical approach to problem-solving serve as a model for all who seek to understand the world around us. His ability to think abstractly and apply his ideas practically has made him a timeless figure in the history of science and mathematics. Archimedes' story is a testament to the power of human curiosity. It shows us that the quest for knowledge is a journey that transcends time and place. His life and work remind us that even in ancient times, the human spirit was capable of reaching extraordinary heights. It reminds us that even in ancient times, brilliant minds were capable of extraordinary achievements. The legacy of Archimedes is a beacon of inspiration, illuminating the path for future generations of thinkers and innovators. brilliant minds were capable of extraordinary achievements. His name is synonymous with mathematical genius, and his work continues to be a source of inspiration and admiration. His name will forever be synonymous with mathematical genius. Archimedes' contributions to mathematics and science are celebrated to this day, and his influence can be seen in countless fields of study. He is truly the father of mathematics. His legacy is a testament to the enduring power of human intellect and the unending quest for knowledge.